Students, welcome back to the second part of lecture number 7. So, here we are going to discuss about data handling. As you understand, data are the key of any kinds of modeling in material informatics. That is what will be your basis for all calculations of modeling. So, now we should have good quality data if you want to do a good model, right. So, how to ensure that you have a good quality data? That is what we discuss in the data handling part. It is quite a lot of things. First, let me tell you what are the different kinds of data we handle. First is obviously the feature data, attribute data. Okay, you must be thinking what is that? Very simple. Suppose you are doing an experiment in which you are calculating temperature as a function of time, right, of any object. Or you can simply say you are measuring temperature of the atmosphere in 24 hours time. That is what is done by the weather agencies, right. They measure temperature every hour, atmospheric air temperature. So, from midnight you start measuring temperatures, go to the morning, then lunch time or noon, then evening, and again evening till midnight you can measure temperatures, okay, 24-hour duration. So, this is your attribute, that is your feature, right, is it not? Temperature is, time is what is you are varying, and what you are measuring is temperature, that is your target values, or what you can say this is a dependent variable. So, this is your data, these are your data, right. So, data can be either numerical, which is very common most of our case, or it can be categorical. What is categorical? Categorical may be yes or no. It is always possible whether you go play tennis or not, that is categorical data. You cannot say 1 or 2, right, you will always say yes or no. You can also have static data or dynamic data, right. Temporary evolution is what just now we talked about it. As the time varies in the day or the evening or night, how the temperature, atmospheric temperature changes, that is what is called your temporal data, right. You do a lot of experiments like that, where we as a function of time we measure certain things. So, hence the data types can be either numeric or categorical, static or dynamical. You can have other kinds of data also, like data distributions. You can also have data like text, wave, metadata, or if you can get data from images, audio, video, whatever. You can convert them into terms of data, right. So, we will talk about how images or audio videos can be converted data in later part of this course, but you understand that data can be in different types. So, now when data are different types, you have to make sure that all the data are good quality, right. That is why we need to pre-process data and handle it properly. What do you mean by pre-processing of data, right? This is something which will come to your mind always. So, first is important aspect is data cleaning. It is just like a cleaning a room. When you are staying in a house or room, after some days it will become dirty, you start cleaning it up. So, every data in this world is basically has lot of noise, right, everything whatever data you collect, does not matter whether you are trying hard to collect the best quality data, there will be lot of noise. You have to remove that noise, that is what is called data cleaning. Many cases you have to integrate data, your data with somebody's data, or your data with published data, right, whatever available, or you may have to transform your data to fit in somebody's data. Both are all not in the same format, right. You will see that, and if the two data are not same format, you cannot open in the Excel format, right. Excel, they are like an Excel book, or somewhere like that. So, you have to make sure the data are transformed to take care of such a kind of transitions. There are cases where you have to reduce the data. What do you mean by reduce data? Data can have many dimensions, right. With dimension, what do you mean by dimension? We can have x, y, z as a 3 dimensions, but a data can have n dimensions. x, y, z 3 dimension, because we can only understand 3-dimensional aspects or visualize that. That is why we do not discuss about it more than that, but actual sense data can have any dimension possible. You are thinking why, how it is possible? Very simple. I have a variable x, okay. It can vary xi, it can vary 1, 2, 3 to xn, right. And for each you have a target value yi, y1, y2, y3, yn. So, this is n-dimensional data, correct. So, many times you may have to reduce the dimension from n to lower dimensions for analysis or for visualizations. That is what is called data reductions. In some cases you may have to discretize data, like an image. If you have a hard image, how to convert in terms of data, that is what is called discretization of data. Many of you do that. You can scan in a scanner and convert into digital data, right. You have an old picture at your home which was not taken by a digital camera, and you want to use it for your update on your social media. What you do is scan it in a scanner, convert it in a digital data, and then use it. So, that is what is called discretization. This is one example. There are many such things possible. Many of you may like to get data out of a curve which has been given in a old textbook, let us say, very good textbook. They provided you a curve or xy plot in which data are provided in terms of a curve, right. So, how do you get that data? You can actually discretize that particular graph using tools available in the internet and discretize that. That is also a process of discretization. So, in a nutshell, preprocessing of data means data cleaning, data integration and transformations, data reductions and discretization. These are the 4 different steps we are going to discuss in this part of the lecture next. Data in real world are really dirty, they are not clean at all. There are many problems. First problem you will see is that incomplete data. That means some data are missing, okay. There are a lot of lazy people who will collect data during experimentation. They may have forgotten to record some data, or they might have slept off during the experiments. So, what will happen? There will be missing values. What you will do? You will go back and do the experiments and fill it up. That is not possible, right. That is illogical also. So, therefore, in the interest of time and interest of modeling, you have to take care of that part, how to complete the data. This is one problem. And then I told you, you can also have a noisy data. There can be a lot of errors or outliers possible. So, errors are what? In experimentation, when you do experimentation, you are liable to do some error or mistakes, right. This is very common. So, when you do a mistake, you have data which are more noisy. It contains a lot of errors. Sometimes you will see, I will show you also, you can also have outliers in the data, some data which are distinctly different from the other data. That is what is called outlier. See, there are also questions of inconsistent data. It can contain discrepancies, right. Very simple. Let us say my age is 42 and my date of birth is 03/07/1917. Does it match? You can calculate yourself, taking today's dates, whatever it is, whenever you are seeing the lecture, if you can calculate that, right. So, you will see there is some inconsistency. So, many times we write rating upon instrument as 1, 2, 3, or rather you give ratings when you are using some app based cab, when you are going somewhere. You can give rating 1, 2, 3, or you can give rating ABC, right. There is a discrepancy between these two. One is a number, one is a letter. Then you can also have discrepancy between duplicate records. Some records have duplicates, let us say some people have copied it, that also can create problem. Lastly, you can have also low quality data, very difficult to understand what is low quality. Everything else is talking about quality, incomplete, noisy data, inconsistency. But low quality data will give you bad results. That means the duplicate, missing data, incorrect entries can lead to a lot of problems. So, now you understand the real data whatever you get is basically contains lot of dots, you have to remove those. So, how to do that? And this is what is important, data preparation, cleaning, transformations, that these all comprises majority of your work in a data informatics. That will take a lot of time for you to do that. So, what are the well accepted factors for good data quality? Obviously, accuracy is one of the most important factor. Then you know the completeness is another factor, completeness is the biggest factor, right. Completeness means it is complete, there is no missing thing. Consistency, there are other factors also. Timeliness, some data are updated every 6 months, right. You can think about it, lot of data available on internet like weather data, that has to be updated on a daily basis, otherwise there is no use. Who is going to see what happened yesterday? Only those who are scientists who are modeling the weather. A common man is only interested in what is going to happen in future, right, in a weather. So, therefore, you are interested to see those data which are available today. That is why timeliness is very important. This has to be updated regularly. Then there are other factors like interpretability, accessibility, whether data are accessible to you, believability. Some people may believe data, some people may not believe. It does not matter whether it is basically a feeling that I do not believe it or I believe it. And last factor is the value addition, are the data are adding any value to your problem or not, or your model into or not, right. So, this is how you can judge, but these 4 factors are the main factors: accuracy, completeness, consistency, timeliness. These are the main factors. Okay. Remember, this accessibility and interpretability are also equally important, but sometimes it may not be accessible, you can pay and get it, but interpretation depends on the person who is handling the data, right. So, there is nothing like a absolute interpretable aspects in a data. So, what you do, these are the things I already talked about it: cleaning, integrations, transformations, reductions and discretizations, right. So, cleaning can be like missing value, smoothing the noisy data, identify or remove the outliers or resolve inconsistency. Integration is your multiple data sets of files, join them, integrate them. Transformation is normalization, aggregations, all kinds of things, transformation possible. Reduction is just, one is obviously reduction in volume, but also you can also reduction in dimensions, and discretization I already talked about it, right. So, let us see cleaning. Data cleaning means filling the missing values, identify the outliers, smoothing the noisy data, correct inconsistent data and resolve the redundancy. Many times there will be redundant data, you have to remove those other redundant data very carefully. So, most of the cases missing data is because somebody has not measured it, it may be that somebody has retained it, okay. Somebody has measured, but maybe because of some reason the data was not written or recorded, okay. That is what missing can happen. So, you can't do anything about it. So, many tuples have no recorded values of several attributes such like customer income in a sales data, this is one such, okay, or maybe temperature during experimentations, other values are recorded, temperature is not recorded, okay. So, equipment can malfunctions, data cannot be entered due to misunderstanding, as I told you. I thought this data is not correct, you thought it is okay correct, but I thought it is not correct, I did not incorporate, or not register in the history or changes of the data possible also, okay. So, what you can do? You can simply ignore those data which are not given and compile those which are available, or you can actually fill the missing values manually, is it not? Manually you can back calculate, it is tedious and infeasible in many cases, or you best is to fill in automatically, right. You can use attribute mean value, okay, or most probable value, interference based such as Bayesian, I gave you Bayesian formula, You can use other algorithms also, okay, these entry or things also do that, right. How to remove noise? Noise can come from faulty data collection, data entry problems, transformation problems, many other problems, duplicate records, inconsistency, all are possible. How to remove noisy data? This is what you should focus. There are three important techniques by which you can remove the noisy data or handle the noisy data. First is called binning. Okay. Binning is something we all of us use in daily life. What is binning? First you sort the data, partition into different ratios. It can be equal depth bins also possible. Okay. So remember, when you put garbages, there are different bins possible, right? We can put plastics in one bin, what is called the glasses in other bins, metals in other bins, right. So this is what it is. Okay. So when you sort the data and partition into different bins, that is what you do when you in household garbage you do, right. So then once you have done that, you can smooth by bin means, right, or using the mean of the bin or meridian of the bin or even boundaries. So I have different bins, segregate the data, sorted out data. I can then smooth by using the mean of this data, or you can sort out by meridian of the data, or you can take out the boundaries, bin boundaries, right. This is very easy. This is what is widely used. And last thing is what? You can also do clustering. Clustering is a part of your algorithm also, we will discuss. So there you can actually detect and remove the outliers. Last thing you can do is you can combine computer intelligence, human inspection, both. That will allow to detect suspicious values and they may be checked by the human. First you can allow the computers to do that, then you can yourself inspect that. So you can understand this two, binning and clustering, is better technique for handling noisy data. Let us talk about one example. Let us say I have sorted data for price of anything, any object in dollars, 4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29, 34. What do you do? I create a 3 bin, bin 1, bin 2, bin 3. Bin 1 has 4, 8, 9, 15, 4, 8, 9, 15. Bin 2, 21, 21, 24, 25, right. Bin 3, 26, 28, 29, 34. So I have basically 12 data, I have separated into 3 bins. Now I smooth, first bin I smooth by the mean. You can clearly see mean is 9, so I smooth by mean. Second case is mean is 23, I smooth by mean. Third case, third bin, mean is 29, I do that. You can also smooth by boundaries. The bin 1 has 4 is the boundary, so 8, 9 are close to 4, so I put it there, and 15 is the last on the right side, right, correct. That is what is called as a bin boundaries. And the 21, 25, 24, 25 is almost similar, so we can use that 21, 25, you can see that 21, 21. Bin 3, 26, 26, 28 is close to 26, and 29 is also close to 26, 34 is separate, it is large different from 26, that is why it has to be considered separate, right. So these are the way you can smoothen and remove the noise. This is just one example I given you. Outlier removals, this is also very big problem. Whenever we are talking about some data available from literature or some experiments, there will be always some outliers, data points which are inconsistent with the majority of the data. So you can see here, these are the different clusters of data, and the red color things are outliers, correct. The blue are actually the real inlier, they are not liar, but these are the outliers, red color things. It's easily you can remove that. So these are the majority clusters, and these are minority clusters, outlier clusters. You can also fit a curve, these become outlier. Am I clear? And you can also do a hypothesis based testing for a given model, that also possible. So therefore, before you actually do a model of a data, you must correct it, you must take care of meshing values, noisy data or outliers very carefully. Now let us move on to data integration and transformations. Well, integration means what? In combine data from multiple sources, like thermodynamic databases. You can have various kinds of multiple source data, you have to combine it and do it. Okay. So, what you do? You can do schema integrations, integrate metadata from different sources, this is very easy. And you can also define the entities, identify the entities, okay, and like A customer ID, B customer ID, two different data, you can just identify them separately. Sometimes you can detect and resolve the conflict between the data sets. You yourself can do that, you do not have to worry about it. So, you can have different scales, matrix versus BTC units, you can detect that and convert it. That is why you can easily integrate data, or you can remove duplicates and redundant data, that is obviously always there, but these two are important, schema integrations and detecting and resolving data conflicts because of the change of scales or different kinds of units, possible CGS, MPS or SI units, right. Transformation is again you can smooth in it, normalize the data, which is always done in machine learning, you can normalize the data and you can scale, you can actually normalization means what? Scaling the data, because you have very small values. So, you scale the data so that small values become useful, and also possibility of attribute or feature reconstruction, okay. New attributes constructed from the given data. You can do aggregation, summation, all these are very common, I do not have to discuss much, okay. Or you can do generalization, like in case of hierarchical clustering, generalization is used. Well, normalization is very simple, you can have min max normalization, you can see V minus new V value is V minus min divided by mean of A divided by max of A minus mean of A, and into new max of A minus new mean of A plus new mean of A, correct. That is how you can actually define new V value. Z square normalization is also possible, V minus mean A divided by standard deviation, and you can also do decimal scaling, that is divided by 10. You can divide a data by 10, then it becomes decimal place, right. So, what is about data reductions? Well, if data is too big to work with, you have to reduce the size of data. So, obtain a reduced representation of the data set that is much smaller in volume, but yet it has the same quality, right, to give results. That is what data reductions. So, this is possible by dimensionality reductions, aggregation of clustering or sampling. Dimensionality reduction is very important, that is why the PC analysis or Pearson analysis comes into picture, that removes all the unimportant features or attributes, okay. I think Professor Pratik will discuss about these aspects when you come back with lectures on the use of material informatics, because this is a critical aspects there. So, dimension reduction is just to give you an idea, it is basically based on feature selections, okay. Select a minimum set of attributes that is sufficient to represent data. How it is to be done, that is what will be discussed by Professor Pratik. And you can always use heuristic approach, which is nothing but stepwise forward functions, stepwise backward eliminations, all kinds of combinations of these kind of techniques also possible to be used, okay. One such thing is a histogram. This is popular data reduction techniques. You could see that in this is a typical histogram I plotted, and you can see that it easily it can allow you to cluster data into different sets, right. You can reduce that, divide data into buckets and store for each buckets. So, one bucket is this, other bucket is this, third bucket is this, fourth bucket is this, okay. You can do that. So, clustering is again same thing, you partition data into different clusters and it is very effective, and there are many choices of clustering definitions, we can discuss much later also. Sampling also possible, choose representative set, subset of data, representative sample. Actually, this is very important when people predict the outcome of election, okay. They choose a small sample and then replicate it for larger populations to give you election results predictions. That is what is sampling. And you can also have adaptive sampling methods, which is stratified sampling, like approximate the percentage of each class in the overall database. This is basically percentage. It can be used in conjunction with normal data or skewed data also. This is what is, you can see, this is the raw data, this is the sample data, okay, much clearly different from the raw data. So, last thing is about discretizations, which is there are different types of discretization possible. You can have nominal values from a unordered sets, ordinal values which are basically from a order sets, and continuous values, real numbers actually. Okay. What discretization does? It divide the range of continuous attribute into intervals, because some data mining algorithms only accept categorical data like yes or no, right, but you have to convert the continuous values into that. That is what is called discretization. So, binning is the best method. You can also use entropy based model methods also, that is possible. So, I do not want to get into all these details of binning and entropy based methods, because we have not taught you. So, when we teach all these methods, we will come back and discuss about that. So, I hope this is in a nutshell is data handling is. So, that sums up our first part of our lecture. That is what we talk about it in the beginning. I will go back. So, introductory concepts are done now. So, in the next lecture we will discuss about how material informatics come in actions. That is where the difficult algorithms comes into picture, gradient descents, regularization on solvers and regressions, and some other MN models. Okay. And slowly you will get into the linear models like support vector machine, decision tree, neural networks, clustering, other aspects in future classes. Thank you.